We are busy with the topic of common fractions. In this video, more specifically, we are going to focus on addition and subtraction of common fractions. So we are going to use exercise 13.2 to illustrate these concepts. For number 1a, we have to calculate 3/5 plus 1/3. Now, the strategy here is to get the denominators or the bottom ones the same so that we can add the tops. So we need to find a number in which both 5 and 3 can go into. Often what will always work is simply to multiply the bottom ones. Sometimes it's possible to get a better solution, but this one will always work at least. So 5 times 3 is 15, so 5 can go into 15, 3 can also go into 15, so 15 will work. So we can make that our common denominator. So in order to get to 15, we had to multiply by 3 the bottom. So whatever we do to the bottom, we have to do to the top. So therefore, we have to multiply the bottom by 3 to get to 15. We therefore also multiply the top by 3. To get 15, we have to multiply the bottom 3 here by 5. So therefore, the top of 1, we will also have to multiply by 5. So 3 times 3 result in 9. We know already we will have 15 at the bottom. 1 times 5 is 5. Again, we know we will have 15 at the bottom. Now, since the bottom portions are the same, we can add the tops. So 9 plus 5 is 40. And next is to see if it's in simplest form. Yes, I cannot think of any number that can divide into 15 and into 14 both without the remainder. So this is the final solution. So I'm going to ask you to try number D. I'm going to give you a bit of time. Strategy would be to find something that both 2, 4 and 3 can divide into without the remainder as the denominator. There would in fact be two possibilities. The one is to simply multiply the 3 bottom ones. 2 times 4 is 8, times 3 is 24, and use that as your common denominator. The other option is to use 12. 2 can go into 12 6 times, 4 can go into 12 3 times, 3 can go into 12 4. So I'm going to use 12. 24 will would also work. So now we can see maybe some of you use 24 and we can compare our answers in the end. So how do I get from 2 to 12? I have to multiply by 6. So at the bottom I multiply by 6. What I do to the bottom I have to do to the top. How do I get from 4 to 12? Yes, I multiply by 3. So what I do to the bottom, I have to do to the top. How do I get from 3 to 12? Yes, I have to multiply by 4. What I do to the bottom, I have to do to the top. So what's 3 times 6? 18. We know we will have 12 at the bottom. 1 times 3 is 3. 1 times 4 is 4. So now everything is over 12 as we wanted, so we can now add and subtract. 18 plus 3 is 21. We have 21, we give away 4. We therefore have 17 12s. Is that the simplest form? Now this is a mixed fraction. So first well, not a mixed fraction, it's an improper fraction. The numerator is bigger than the denominator. So we can in fact change to a mixed fraction. First see how many times 12 go into 17 once. What's the remainder? Well, the difference between 17 and 12 is 5. We always keep the bottom the same. So we have our whole part, we have our fraction part. This is our mixed fraction in simplest form. And the guys that use 24 throughout as the denominator should get the same answer. So number 1B, we have to calculate. In this case, we are given mixed fractions. The strategy most often, if you are given mixed fractions, probably 99% of the case is just to change it to improper fractions. So how do we do that again? We take the whole number, multiply by the denominator, add the numerator, and keep it over the denominator. So 2 times 5 is 10. 2 times 5 is 10 plus 1 over 5 plus 5 times 8, which is 40 plus 1 over 8. So this 10, well, let's rather write it as 2 times 5 to be more precise, plus this 1. So we have 10 plus 1, so it's 11 over 5, plus 5 times 8 is 40, so we have 40 plus 1, so it's 41 over 8. Now we know we need to get something in which both 5 and 8 can go. Well, 5 times 8 is 40, 40 will always work. So we had to multiply 5 by 8 to get to 40. What we do at the bottom, we have to do at the top. How do we get from 8 to 40? We multiply by 5. So what we do to the bottom, we have to do to the top. So 11 times 8 is 88. We know we have 40 at the bottom. 41 times 5, well, let's see what's 40 times 5. 4 times 5 is 20, times 10 it's 200. And 1 times 5 is 5, so it's 205. over 40. Let's just show here 41 times 5. 1 times 5 is 5. 5 times 4 is 20. 205. So now the bottoms are the same, so we are allowed to add and subtract. 205 plus 88 is 293. Is this in simplest form? No, it's a improper fraction, so we can change to a mixed fraction. 40 goes into 293 how many times? Well, 40 times 7 gives 280. So we have 7 times 40 is 280. We still need 13. 280 plus 13 gives 293. So the remainder is 13. The bottom always stays the same. So it's the same as 7 and 13/40ths. As a mixed fraction, we have our whole part, we have the fraction part. So I'm going to give you the opportunity to attempt this one. I'm going to give you a bit of time. Hint is first step will be to change the mixed fraction into an improper fraction. Okay, so how do we change a mixed fraction to an improper fraction? Take the whole part, multiply by the denominator. So we have 2 times 3, add the numerator, keep the denominator. Other portion is already a proper fraction. So now we can simplify. 2 times 3 is 6. 6 plus 1 is 7. So we have 7 over 3 plus 3 over 4. The denominators are not the same. We need to make them the same. 3 times 4 is 12. 3 can go into 12 without remainder. 4 can go into 12. So to get 12, we multiply the 3 by 4. What we do to the bottom, we need to do to the top. So we also have to multiply by 4. To get to 12, we have to multiply the 4 by 3. What we do to the bottom, we have to do at the top. So we also have to multiply the 3 by the 3. So 7 times 4 is 28 over 12. 3 times 3 is 9 over 12. Now we can add, since the denominators are the same. 28 plus 9 is 37. Is that in simplest form? No, we have an improper fraction. We can change therefore in a mixed fraction. 12 goes into 37, 3. 3 times 12 is 36. We have a remainder of 1. We always keep the bottom the same. So it's this 3 and a 12. That's our final answer. Number 2. By how much is 2 3/4 more than 1 5/6? Can you remember in the past we have dealt with problems like that or like this? We said if something seems complicated, make it easy. Let's change this to ask by how much is 2 more than 1? Well, you will tell me, sir, that's easy, it's 1. How did you get that answer? Well, you said 2 minus 1 equals 1. So now let's do that with the hard part. Instead of 2, we now have 2 3/4. Instead of 1, we have to subtract 1 5/6. So now we know what to do. So now we have mixed fractions. First change to improper. 2 times 4 plus 3 over 4 minus 1 times 6 plus the 5 over the 6. So 2 times 4 is 8 plus 3 is 11 over 4 minus 6 plus 5, 11 over 6. We need now, since we are subtracting the denominators the same, 12 will work. 4 goes into 12 3 times. 6 go into 12 2 times. 6 times 4, 24 also would work, but let's use 12. So 4 we have to multiply by 3. What we do to the bottom, we do to the top. 6 we have to multiply by 2. What we do to the bottom, we do to the top. So 11 times 3 is 33 over 12 minus 11 times 2 is 22 over 12. Since the bottoms or the denominators are the same, we can make it common. So 33 minus 22 is 11/12. And I believe that is in simplest form. We can't find something that can go into 12 and into 11 without remainder. So similarly, number 3, what must be subtracted from 10 7/8 to give 4 1/4? Well, we could change it. What to subtract from 10 to give 4? 10 minus what is equal to 4? So this is in fact an equation. We could therefore say the answer we are looking for is question mark. Let's swim it to the other side, then we have a positive question mark. A negative, if it swim across the river, becomes a positive. 10 is already on the right correct side of the river. Let the 4 swim across, plus 4 becomes negative 4. So 10 minus 4 gives the answer. So now we can just use the more complicated portion to substitute. So 10 is now actually 10 7/8. We have to subtract from that 4 1/4. That will give us the answer we are looking for. So now we have mixed fraction, so we can say whole number times denominator plus numerator, so whole number times bottom number plus top number over bottom number or denominator. Same thing here, so it's the whole number times the denominator or bottom number plus the numerator or top number over the bottom number or denominator. So 10 times 8 is 80. 80 plus 7 is 87. 4 times 4 is 16. 16 plus 1 is 17. Now we need the same number at the bottom. So in what can both 8 and 4 go? You could say 8 times 4 is 32, but in fact 4 go into 8 twice, 8 goes into 8 once, so we can simply use 8. 8 will work. How do we get from 4 to 8? Yes, we multiply by 2. What we do to the bottom, we can do to the top, or should do to the top. So now we have 8 as common, and we have 87. 17 times 2 is 34. So what's 87 minus 34? 7 minus 4 is 3, 8 minus 3 is 5. So it's 53 over 8. Is that in simplest form? No, it's an improper fraction. We can change as mix. 8 go into 53. 6 times. 6 times 8 is 48. What's the remainder? 5. So it's 6 and 5/8 as the final solution. So let's focus on a word problem. Every month, Ludwig spent a sixth of his pocket money on paper, 2/3 on pencils, and 1/12 on pens. What fraction of his money can he spend every month at the tuck shop? So let's see. So we have a sixth of his pocket money is on paper. Two-thirds he spends on pencil. And the 12 on pens. So if we add up all of those fractions, we know what he spends other than on the tuck shop. So, but now once we know what he spends on the tuck shop, well, on not the tuck shop, what he spends on other than the tuck shop, we will have to subtract that from what he has in totality to get what he spends on the tuck shop. So we are saying, let's take the whole, everything he has, and subtract from that which he spends on other things than the tuck shop. So what he have, less what he spends on other things, will give what he has to spend on the, or what is remaining to spend on the tuck shop. So we have in fact 1 minus, according to Botma's first two brackets. So since we are adding, we need something common. Well, 6 can go into 12, 3 can go into 12, 12 can go into 12. So 12 will work. So you could say we have to have 12 as our common denominator. So we know 6 times 2 gives 12. So what we do to the bottom, we have to do at the top. Plus, let's make it a bracket like this to distinguish between our inside brackets. 3 times what gives 12? 4. So since we multiplied the bottom by the 4, we need to multiply the top as well by 4. 12, well, we already have 1 over 12. 12 times 1 gives 12, 1 times 1. So we have in fact 1 minus over 12. If we simplify, we have 2 plus 8 is 10 plus 1. So we have 11 twelfths. Now 1 we know is the same as 12 over 12. 12 divided by 12 is 1. So we have 12 twelfths minus 11 twelfths. So since both the denominators are the same, we can subtract the numerators. 12 minus 1 is 1. So 1/12 remains to spend at the tuck shop.